Example 1 here on correlation and regression is taking a look at correlation. So here we're asked to plot a scatter graph for this given data, and then we're asked to describe the correlation of this data. So here, before we go on to plot this scatter graph, just take a minute here to take a look at the data and see if you can identify what correlation would be associated with this data. Now in terms of plotting the scatter graph, this is rather straightforward. All we need here is our x-axis and y-axis, and notice the data for the x variable here only goes up to 8, and for the y variable this only goes up to 20. So plotting this is rather straightforward. All we obtain is this here. Okay, so notice to get our first coordinate here, or our first point on the scatter graph, we go 1 unit across and we go up 1 unit here. Okay, so that corresponds to 1, 1 there. Our next point is 2 units across and we go up 4 units. So we go across 2 units here and we go up 4 units there. Okay, again following this pattern here, 3, 6, so we go 3 units across and then we go up 6 units there. Okay, and like we can see, the rest of the points we just plot then as we go along. Okay, now we can easily identify the correlation now based on this scatter graph. So taking a look at this scatter graph here, we notice the points are going in this general trend here. So we're starting in this bottom left corner here, we're going all the way up into the top right corner. So in that case, what we can see here is that as one of the variables increases, so as x increases here, we notice y also increases here. Okay, so in that case, as both the variables are increasing, so as x increases, y increases, what we've got here is positive correlation. Okay, and we could identify that from the data, which is what we mentioned at the very beginning of this video. As we notice here, as the x variable increases, so 1, 2, 3, 4, all the way up to 8, we notice the y variable also increases, 1, 4, 6, all the way up to 20. Okay, so that would give us a good idea that we were looking at positive correlation there. Okay, so that gives us the solution to example 1 on correlation. Example 2 here on correlation and regression is taking a look at regression now. So we're told some data is collected about the temperature of the water in a kettle in degrees Celsius over time in minutes. So we're given the equation of the regression line here, and we're asked a few things here. So we're asked what's the gradient and y-intercept from this given equation, and what do these mean in context of the experiment. We're also asked how long does the kettle take to boil. So first let's start by identifying the gradient and y-intercept. So the equation we've been given here is y equals 20 plus 40x. So the first part, just identifying the gradient and y-intercept, is straightforward if we can just simply identify the equation of a straight line here. So in this case, this is just the form for y equals mx plus c. The other thing to notice here is they've written it as c plus mx, but of course this doesn't matter here. So all we need to identify then, based on this, is that this represents our c here, so therefore c equals 20 and m equals 5. Okay, so in this case that means the y-intercept is 20, my y-intercept is 20, and the gradient is 40. Okay, so the gradient is 40. So the gradient is 40. So let's take a look now at what these mean in context of this equation and the context of the question. So here we know the y-intercept is 20. So in that case, what that means is the temperature of the water at the very beginning, when the water starts boiling, is 20 degrees Celsius. If we let x be equal to 0 here, that means we just started, that would give us y equals 20 plus 40 times 0, just giving us y equals 20. So therefore, what this means here, so therefore, the y-intercept here represents the initial temperature here, or the starting temperature. Okay, so that means it represents the initial temperature of the water. Okay, so we just write that down in full here. So that tells us what the y-intercept represents here, and that starts at 20 degrees Celsius there. Okay, so we just know that down. For the gradient then, what the gradient tells us here is this represents a rise of 40 degrees Celsius every minute. Okay, so therefore, the gradient here represents represents a rise of 40 degrees Celsius every minute. Okay. So what that's told us there now is the gradient represents a rise of 40 degrees Celsius every minute. Okay. And finally, we just asked how long does the kettle take to boil? So here, let's just clear everything we've got on the screen now. So how long does the kettle take to boil? Well, the kettle finishes boiling at 100 degrees Celsius. So what we're stating here is that 20 plus 40x is equal to 100. So in that case now, all we need to do here is solve for x. Once we've got that value of x, that tells us how many minutes it will take for the kettle to boil. So subtracting 20 off both sides of this equation, we obtain 40x is equal to 80. And then in that case, dividing by the coefficient of x here, we obtain that x is equal to 80 divided by 40, which gives us 2 there. Okay. So in that case, that x represents minutes, so therefore this takes 2 minutes there. Okay, so that's how long it takes the kettle to boil there. And that gives us the solution to example 2 on regression.